Alright, so this video here is kinematics, distance, and displacement. This is by me, Dario Santiago, and Chris Venezia. Alright, so the first slide here, what is distance? The first bullet says that distance is how far the object has moved. Next bullet says the variable of distance is known as a scalar, so here it doesn't have a direction. An example of this is the object traveling 15 meters. See, there's no direction after that. Next slide. Alright, displacement. On the flip side, displacement is how far an object has moved in total with respect to the origin. The displacement of an object is represented as a vector. In this case, there is a direction. Example here, the object has traveled 15 meters east from the origin. Like I said before, the displacement has direction, and it must be recognized. It's very important. Next slide. Alright, this picture here. There's a rectangle with different distances, and this guy starts at point B and he travels in distant directions. So if at this time, if you want to pause the video, you can set up example problems or just talk through it. So if the guy starts at point B and goes to point C, he travels 8 meters. And the displacement of that is also 8. So if he starts at B and goes all the way around, his displacement would be 0. Alright, next. Alright, kinematic equations. The equations for distance can be represented in multiple ways. The first equation says the final distance equals initial distance plus vt plus 1/2 at squared. Second one says v squared equals v naught squared plus 2a and then delta x, so the x final minus x initial. The last one says delta v times delta t equals delta x. And then from math class you probably know this one at the bottom, which is the distance formula. Alright, so x final equals x initial plus vt plus 1/2 at squared. So this in a little bit more depth is the final distance is equal to the initial distance plus the initial velocity times 1/2 at squared. And then to solve this, you just get the information and plug in and just use simple algebra. Alright, next slide. V squared equals v naught squared plus 2a delta x. Alright. In words, to solve for delta x, you must rearrange the equation to v squared times v initial squared, and then divide that by 2a, and that gives you the delta x. This will give you the distance the object has traveled in a certain time with a certain speed. Alright, and then this one here, you get the change in velocity times the change in time, and that gives you the change in distance. And that's basically it for that one. Alright, and then this equation, like I said before, it's from like math classes. You take from a graph, you get the 2 points and plug it into that equation. This is an equation you would use if you're trying to find the distance between 2 points on a graph. It's the square root of the first point on the x-axis minus the second squared plus the first point on the y-axis minus the second squared. So in simpler terms, usually you just solve the changes on each side, square them both, and then do the whole square root over the whole thing.